Hi, Calculus 1 students. So this is the last exercise of the chain rule section, and it's a pretty hard problem. Okay, so well, it's the end of section exercise, of course. It's like the hardest problem that I'm presenting in class. I should say, however, it's the hardest derivative, right? Because there are problems like that ask for conceptual understanding that are harder than this. But as far as derivatives are concerned, this problem is pretty hard because it relies on multiple applications of the chain rule, as well as the product rule. You can see that we will have to do a product rule inside. So we will have to use the inside-outside rule very efficiently and very cleanly, like very neatly. Let's put it this way. So we want to differentiate this function, okay? The first thing you should always do before you start differentiating, especially a beast like this, is to prepare the field. Okay, so you want to simplify the function. Okay, well, I say simplify the function, right? What I mean by this is actually write it in a way that the derivative will be easier to perform. So when I say simplify, really what you should think about is what would make the differentiation rules easier to apply. And typically what you're going to do, so cotangent cubed, there's not really a way around it, but it might help to actually write it as its definition. So in other words, like big bracket, cotangent, and let's write, hopefully I won't write too much over here, but I'll push the boundary if I need, to the power of 3. So it might help to write it like this, just to make you aware that the outside function is actually the cubic function, not the cotangent. Okay? By the way, it's a mistake that is commonly done to think that the outside function is cotangent. Okay, then we have here x e to the power of, and okay, so 1 over x by itself is not complicated to differentiate, but it can throw you off because it's inside like a big derivative. So what I would do here is I would turn this into x to the -1, okay? And now be careful. X to the -1 is the exponent of e, okay? So it's not like e to the x that's to the -1. It's really like the exponent of e is x to the -1. So be wary of that. Now here, you're gonna use the same rule of exponents to put 2 at the top. So you will have 2 to the power of -x². Now, be careful of the priority of operations when you do this. Okay, so this way, the function is the easiest to differentiate. However, it's even like this, it's not a piece of cake. So be careful as you apply the outside inside rule. Okay, so I'm gonna use as much color as I can. So first, the most outside function is this. It's to the power of 3. So using a first outside inside rule, we have 3 times the bracket, like the big bracket like this, squared. Okay. So, and as you can see, you're gonna have like, this is the next function to differentiate. So you're like, what you're putting here is actually the entirety of it. So it's gonna be like the cotangent of all the rest. Okay, so all of this is gonna fit inside. And you're gonna do the derivative of cotangent, which is, now I have to be careful. It's gonna be multiplied by negative cosecant squared of, okay, and actually I will need 2 lines, I think, for this derivative. So hopefully you won't get confused, but it's necessary. Okay, so now let's have a look. So this is now the new inside, okay? And actually, maybe we could actually stop there for a moment. Just like, okay, so we have this inside that we're gonna take the derivative of. And here we should stop because as you can see, we will have a product rule to deal with. And also like a sum. Okay, so this should be like derivative of. And unfortunately, oh, I know what I'm gonna do. I'm gonna push that bracket a little bit. So like this, and then we have here the derivative of the rest, which is x e to the x to the negative 1 minus 2 negative x to the 2. All of this is being primed, okay? All right, now let's write the inside function in every place. So x e to the x to the negative 1 minus 2 to the negative x squared. Okay, so that goes here. That goes also here. Oh, 2 to the power of negative x squared. Okay, so we have everything. That's good. All right, here I would be actually interested to, yeah, let's write this cosecant squared as being a sine squared at the bottom. This will help us to save space, okay? So the next step should be to, let's first deal with this, simplify this as much as we can. So we're gonna have 3 cotangent squared of this, like x e to the x negative 1 minus 2 x to the negative x squared. And we're going to simplify this later. And then we're going to divide by sine squared of the same thing. Now let's deal with this derivative. So first off here, you're going to have a product rule. So using the product rule, you will have here the derivative of the first, which is x, times the second, e to the x to the negative 1, plus the first, times the derivative of the second, which is also an outside-inside rule. So the outside function is e to the x, so its derivative is e to the u, like that's what I mean. And then the inside is x to the negative 1, which makes this derivative negative x to the negative 2. Okay, so we've done here the product rule. Minus here another outside-inside rule. Now be very careful because the outside function is not e to the u, it's 2 to the u. So its derivative is actually 2 to the u. So let's actually write like the negative x squared. ln of 2, right? You have to actually put the ln of 2 multiplied by the derivative of the inside, which is in this case negative 2x. Okay, then you could continue to simplify this if you wanted to. However, at this point, I will tell you that most of the time, if I ask you a derivative that's as big as this, it's because what I'm aiming for is to check if you know your differentiation rules. So most of the times, I will not ask you to simplify this further. Although you certainly could. You should, if you wanted to simplify this, you should actually rewrite this in a way that it was written here. But otherwise, I will accept this as the final answer. I hope this helped. See you either in the next video or in the next class.